So welcome back, guys. So today my topic is force on moving charge in a magnetic field. So here F equal to, directly I am explaining, so I'm not giving how this and all coming. So force on a charged particle F equal to Q into V bar cross B bar. So you know force is a vector. Here velocity and B magnetic field are also vector. Q is scalar. So the cross product of V bar and B bar gives the direction of force. So now QVB sin theta n cap. N cap is direction of force which is perpendicular to V bar and B bar. So hereafter theta is equal to 0 or 180. That means parallel means in the magnetic field, in external magnetic field of bar magnet, or the field which is inwards due to circular coil. So circular coil current is clockwise, then field into that coil. So now outfield. So these are the representation of outfield, means field is representing outside. So north pole is this side, face side. This is outfield. So out means, already in previous class I explained, phase rule. The current in the coil is anti-clockwise direction. So thumb indicates outwards, our side, our face side. So that is represented by out. So here for suppose current in clockwise, the current in clockwise, the field is inside. That means thumb towards the computer. Some indicates into the computer. So here field. So when the charged particle is parallel to this, projected with some velocity v, a charged particle parallel to this magnetic field, the are anti-parallel to magnetic field. So this is, for example, positive k cap you have taken. Then velocity of the particle is also k cap or negative k cap, means along positive z axis or negative z axis. So there is no force, because you can see here clearly the force is equal to v bar cross b bar. So that means, so cross product of similar means same vectors, unit vectors is 0, because I cross I, j cross j, k cross k, or the cross product between the parallel vectors is 0. So this is in vectors, product of vectors we studied. And angle between the parallel vectors means k, k, j, j, I, I is also 0. If they are negative vectors means 180. So in this case, on the particle which is projected such that angle between B and velocity of the particle is 0 or 180, force is 0. If projected perpendicularly, then force is maximum, that is equal to QVB. Maximum is QVB. If other than theta, other than this angle, if theta is other than 90, theta is not equal to 90, it will be between 90 to some angle. So here you have to understand what I am trying to tell. With some angle I am projecting, then the particle have it experiences some force that equal to QVB sin theta. And here when particle experiencing the force, so its path also have to divide, means decide its path in what way it will move, parallel or anti-parallel, along the field line it will move, in how it will move, what is the path, parabola, straight line, circle or ellipse. That is depends on this formula only, QVB sin theta formula. So now direction of force according to cross product, because force is a cross product, V bar and V bar cross B bar, therefore it is perpendicular to V bar or B bar or the containing the plane which is containing the plane of V and B to that perpendicular. And here the plane of the particle, that means if it is a circular path, x of that plane, x of the circle is parallel to B. For example, here the charged particle is moving in this direction, charged particle in this field, in field or outfield, the charged particle is moving along this path. So this circular path have axis means that is called as plane axis, is parallel to these fields. So I will explain in this here, in this question, this explanation you can understand it. So now see, finally we came to know the charged particle which is projected perpendicularly or other than 0 or 180 then it experiences the force, that is final. So now here I am trying to explain how much force and how it will be move. So now see here in this example, the particle is moving along x-axis, consider that is I, and here field is into, that is positive k, so that equal to some b naught k cap consider. So now when it is projected perpendicular, now this is a perpendicular, I and k are perpendicular, it experiences force. Okay, now F is equal to Q V B naught into I cross K, because V bar cross B bar, I cross K. So that equal to Q V B naught I cross K. So in cross product already we discussed K cross I is equal to J, K cross I equal to J, but here I cross K is equal to minus J. Therefore, on this particle when it is moving in magnetic field, the force acting in negative J direction. This is the direction of force. And this can be calculated, means the direction of the force, the given by on a charged particle. Actually, this law, Fleming's left hand rule, which gives the direction of force on a current carrying conductor. But here the same rule we can apply for charged body also. But here about this, the Fleming's is not given anything. So here we will go only direction of V bar cross B bar. So now because of this force, the path of this means, so when there is a force acting on this particle when entering into field, the path is changed into circular path. Continuously force acting, right? The everywhere perpendicular to the motion. The force is acting, so it will be changed its path into circular. So therefore, when charged particle perpendicularly enter into the field, the path is circle here. So path is circle. Whereas the same charged particle enter into electric field perpendicular, the path is helical path, means parabolic path, perpendicular to electric field. And here, because of circular path, the work done on the particle by magnetic field is zero. So therefore, its kinetic energy, its speed, velocity continuously changes, but speed not changes. So uniform motion, it will move uniformly. But whereas in the electric field, the same charged particle, kinetic energy changes. So work done is not equal to zero. That means speed also changes. But here, the quantities, kinetic energy is constant, speed is constant, but momentum is continuously changes because velocity is changing in the circular path. We know that is because it is uniform circular motion. And it is uniform circular motion, so we can take V is equal to R omega also for calculating angular velocity and time period. So now coming into the concept. So here the magnetic force which is acting on the particle by the magnetic field QVB is equal to the centripetal force in the circular path with radius R. So from this, the radius of the path of the particle in the magnetic field is equal to mv by qb. So that equal to p by qb. P means momentum of the particle. So now, if this electron have initial kinetic energy, or it is getting the velocity initially by some source which is giving velocity kinetic energy, then the P means we know that equal to 2 mk by qb. So the R value we can write like this. So the radius of the path of the particle which is entering into the magnetic field perpendicularly depends on mass, initial velocity and charge, or q by m ratio in the field B, in the considered field B. If one particle is coming into one field of strength B and the same particle is coming into another field strength, either it is more or less, how the path will be means less or more the radius, and deviation, that is the different topic. In the deviation topic I will explain. So B, how much should be not to come out of the magnetic field, the particle, where it will come out, how much deviation. So here it is called deviation taken place here, right? So here it is in the field strength is more, so it is every time deviation taking place. So may sometimes it will come out of this without completing the circle, it will come out. So that we will discuss in deviation topic, not here, right? So now radius is depending on mass of the particle. That means if here proton they are projecting, alpha particle or deuteron or electron, so that depends on mass and charge of the particle into the field and how much velocity they are projecting. So radius is depends. And as we discussed, it is uniform circular motion, it is moving in circular path. So I can tell V equal to R omega, then omega is equal to V by R. So from this equation I can write omega is equal to V by R, that equal to QB by M. And time period is equal to here 2 pi M by QB. So now time period of a particle is independent on particle's radius, means one particle is moving. So this is the proton, for example. So this path is anti-clockwise direction like this. So if it is alpha particle, so it will move more radius, but time period is not depends. The time taken is same for both the particles. Only radius will be varies, but time taken is same. That means time independent on radius and velocity of projection and velocity of projection. How much velocity projected? It depends only magnetic field and mass and Q. Means specific charge will tell. Means it is alpha particle or a deuteron or a electron or a proton. So the Q by M and B, how much value of B you have taken. So it is depend on those values. Depend on the time period. Time period is independent. Time period is depend on Q by M, specific charge, Q and M, and magnetic field. Independent on radius of the path and how much velocity. Velocity depends on the velocity, radius will come. So it is not depending on velocity, means undependent, radius also did not depend. So time period for both the particles which have different circular path with concentric circle. So it is same only. Independent on these values, depend on these values, Q by M and B. So this is about when charged particle moving in the magnetic field perpendicular to the magnetic field, means with 90 degrees. Already in the explanation I have given when theta and 180 there is no force, so it is no field. Now the particle is projected with some angle. So here theta. So now, and here the B is acting along I cap. This velocity have two directions. One is V cos theta, and one is V sin theta. The components of velocity in two directions, V cos theta I cap and V sin theta j cap. Here V sin theta component, that is j cap, perpendicular to B I cap. So j cross I is equal to minus k. That means the force on the particle will be out of the plane, out of this screen. That means it will be turned in helical path, and we studied that the path is circle, helical path here, and it continues. So in this, the path is means the plane of the circle, means axis of this plane is parallel to, means the particle moves, the plane of the particle moves parallel to field direction. So this is a very important point. Means if I suppose, so in the same diagram, the magnetic field is acting along the BJ cap. Suppose, consider the magnetic field is parallel to BJ cap, and the particle is projected with velocity by making angle theta here. So x axis and y axis. So now here V cos theta component and V sin theta component. Here the path of this particle means it experiences the force by the vertical component V cos theta. That means the path is like this. It is helical path along the field direction. The plane of this path, means circular path, it axis, the axis of this plane is parallel to field. And now here the velocity is in the projection of the path into YZ plane is, means when here in this case, so this path is in YZ plane. In the YZ plane it is circle, and the XY plane or XZ plane is in helical. That means sinusoidal, right? So circle and ellipse means straight line, side up. So that's why sinusoidal, sine wave. So here it will get here. So in the time to time, the helical path have some pitch, means circle to circle there is some gap. So this gap is called pitch. Means the distance between to constructive position of a particle, means charged particle in the magnetic field is called pitch. So linear distance. So now that is equal to, the pitch is equal to here the V cos theta into T, I can say. So here T already we find out, T is equal to 2 pi M by QB. So that equal to 2 pi M V cos theta by QB. So whereas here if it is coming, so this is the pitch between these two lines is, means these 2 points, linear distance between the two positions of a helical path. So pitch is equal to V sin theta into T here. So that equal to 2 pi M by QB into V sin theta. So the theta, either cos theta or sin theta, depends on the projection and field direction, pitch value. You can come, it is cos theta or sin theta. So I hope you understand up to now. So now projection of the particle into the magnetic field perpendicularly circular path other than that 90 degrees, some angle except to 0 or 180, it will be helical path. That means circle in one plane and a sinusoidal wave or sinusoidal curve in another planes. So that is, and the line of the axis of the plane is parallel to magnetic field. These points you have to remember in this. And problematic formulas are the pitch they will ask, and time period they will ask, and maybe sometimes they will ask on the radius related questions or the related path questions also they will ask. So I will explain all those problems how they are asking on these topics. First we will understand the concept here. So next one. So the force D2, if there is, up to now it is studied about the charged particle projected into magnetic field alone. So force is equal to QVB, that is equal to mv square by r, radius, time period, angular velocity, and radius depends on time period depends on. Other than 90 means how the path will be and in what direction it will move. So all those things we studied. So now coming into the particle is projected in the combination of fields. So in combined fields. So particle projected into combined fields. So when the particle projected into combined fields, that means electric field and magnetic field. We know the force on charged particle F bar is equal to Q into E bar. So Q means here positive charge only, negative charge is minus QE. So force on a charged particle is equal to QVB sin theta. So or Q into V bar cross V bar into N cap. So this cap direction is the cross product of V and B. So these are the two forces on charged particle. So in electric field, the force already in similarities we discussed in Bayes-Sauer's law. So it is not oriented with angle, the electric force on the charged particle, but magnetic force and magnetic fields oriented with theta, means orientation, how it will be projecting the velocity. So now first all are collinear. That means see, all particles means all field, all directions are collinear. Means this is the electric field E bar, and this is the magnetic field B bar. So here charged particle is projected with U velocity. So then here net force F net, and the charged particle is positive charge only, consider proton. So net force is equal to the electric force as well as magnetic force. So electric force is here Q into E plus magnetic force is 0 because U and B are parallel. So theta is equal to 0 sin 0 0. So you understand this. Therefore F net is equal to Q. That means M into A is equal to Q into E. Then other is the particle here only Q by QE by M. So like this you can find. So this is one case when all fields means field by electric field, magnetic field, and the charge is direction of charge is collinear. So in this case only it experiences electric force, magnetic force is 0. And coming into here, it is only because of electric force the velocity of particle changes, momentum changes, kinetic energy also changes. All quantities are changed, and these are respect to direction of the field they are changing. So velocity increases, kinetic energy increases, momentum increases in the direction of field. So now all are perpendicular. Now another case. So field, all fields are perpendicular fields. Means V bar, E bar, and B bar are perpendicular. All mutual perpendicular. Next case. So in this mutual perpendicular case, consider first of all. So we have to define the directions of field. Mutual perpendicular means. So now we'll take the B is along I cap. B is equal to B naught I cap, and E is equal to E naught J cap. So it is perpendicular, and V bar is equal to then K cap. We'll consider. So that is you consider K cap means V naught in K cap. So all are mutual perpendicular I J K. So now electric field, electric force F net is equal to means that consider like this. So this is B naught, this is E naught, and velocity is projected like this. So means perpendicular into I projected. So now D to B, so there is a force, magnetic force. D to magnetic field, there is a force, magnetic force, that is equal to Q into V naught, B naught, K cap cross I cap. K cross I is equal to J. So that means it is along electric field. So now it is along, so electric field is J cap now. So now electric field is also means along the means force on charge body due to electric field is along K cross I is J cap, right, into Q V naught V naught. So now electric force is equal to Q into E bar. So in the same direction of E, that is equal to QE. Therefore net force is equal to F net is equal to Q V naught B plus QE J cap. Both are in J cap. So this is, if any one direction I am changing, the E is, for suppose, in the same case, mutual perpendicular. In the same case, consider now, here V alone, the projected, charge particle projected in the direction of V naught I cap, and B is B naught K cap. So consider change direction. The E is same. So here B naught is equal to K cap. B naught K cap. E is not changing. Direction of E is not changing. So E is along J cap alone. Now the diagram. So E is J cap. So now here field is into the field. So perpendicular direction into field, and particle is projected along the I cap. So this is along I cap, V naught I cap. So here B is equal to B naught K cap. So it experiences two forces again, that is equal to magnetic force. Magnetic force is equal to Q V naught B naught into V bar cross B bar, that is equal to I bar cross K bar. So that is equal to Q V naught B naught into minus J cap. Similarly, electric force. Electric force on a positive charged body is along the direction same QE J cap. So now, for suppose Q naught V naught, Q V naught B naught is equal to QE, consider. So the net force is equal to here subtraction. Fe net force is equal to here Fe minus Fm. So now that is equal to 0. Suppose the force on this particle due to this field, amount of this field and amount of this electric field, and velocity, the combination, this value and this value is equal. The net force is equal to 0. Then the velocity of the particle is equal to, the ratio of velocity of the particle is equal to E by B. This is called velocity sector, V naught. So this velocity is equal to, means V is equal to the ratio of electric field for magnetic field. So this value used to find out, mean this method or value to use to find out the specific charge. So in J.J. Thomson experiment, so it is used and derived specific charge by using J.J. Thomson experiment. So now I will take another model of application, charged body moving in electric and magnetic field. So initially I have to mention the relation between the forces, the total net force in all the cases is equal to QE plus Q into V bar cross B bar, right? So now we are discussing about the cases of this one. So that equal to Q into E bar plus V bar cross B bar. So this is this force here. This net force is called Lagrange force because initially is given this formula, means when charged particle is moving in both the fields, the net force formula is observed by, and idea is given by Lagrange force. Lagrange. So this is called Lagrange force. So now coming into field is perpendicular, field and B, these two field, electric field, magnetic field are parallel, and V is perpendicular to any one of perpendicular. So let so E is acting, the E is acting parallel in the same direction, field also acting. So now perpendicular means E and B are perpendicular, therefore V is projected. So here there is a charge projected with V velocity in J cap, perpendicular to E bar and B bar. So now, so there is two forces. One is by electric force. So electric force is equal to Q into E. So that is I bar, and acceleration of this particle is equal to force by M, Q by M into I cap. After some time, the velocity of this particle is equal to Q by M into T after some time, because initial velocity is 0, so I cap. So the velocity of the particle due to electric field is I cap. Similarly, by the magnetic force, the plane of this particle is perpendicular to, means it will be, the circle is like this, helix path, and this pitch of the helical path is, the pitch of the helical path. So this will be more like this, parallel to B. We should know something what happened. It is not answering. So pitch of the helical path is along the parallel line. Oh, okay. So now F is equal to, where F of magnetic force is equal to Q VB and J cap cross I cap. That means it is Q VB minus K cap. The force direction is minus K cap, but path is along, the path is along helical path like this with variable pitch. So helical path means in a plane, the velocity will become in YZ plane, because field is along I cap, the motion is in YZ plane. So now the velocity of this particle due to Fm, I can write V cos theta, so J cap plus v sin theta k cap. So means it is in yz plane. So that is equal to, I can write v cos theta into, here theta will be omega t after some time, and v sin omega t k cap. This k cap and this is j cap. Therefore net velocity of the particle is equal to, it is here I cap, j cap and k cap. So that equal to v into cos. So we know helical path, the omega value is equal to, means in circular path omega value is equal to qb by m, right? qb by m into t. So j cap plus v sin qbt by m k cap plus I cap. So that equal to qe by mt into I cap. So this is velocity of the projectile, means velocity of the particle which is projected in electric field and magnetic field, where electric field and magnetic field are parallel. The velocity is perpendicular to both the fields. So this is velocity. And here the pitch is not uniform, because in the x direction the velocity is increasing by the electric field. Velocity is there. It is not only velocity of or acceleration of magnetic field to become uniform field, uniform pitch, but here pitch is affecting by electric field also, electric force also. Therefore pitch is not uniform. So now whereas next model, E is perpendicular to B. E is alone perpendicular to B, and V is also perpendicular to these two. The before case E is parallel to B and V is perpendicular. V is perpendicular. Here also E is perpendicular to B and V is perpendicular to any one of them. Or in, it is in projection, not perpendicular. You go with it is projected. Perpendicular means again mutual perpendicular will come. So that case is over already. So now here I will go with V is projected from rest. So V is projected from rest. So instead velocity 0. At t is equal to 0, the V of the particle is 0 in both the fields. So now let's consider the E is along I cap, E not I cap or E I cap we can take. The B is J cap. And V is projected with some angle theta like this. So now along E there is a force on the charged particle, the charged particle. Along the B, it will move helical path like this along the B. So we know this because the circle is compulsory parallel to the means the axis of helical path is parallel to B. So already we studied this. So like this. So now here it has, for example, I projected the particle in the plane. So now the velocity is having only x component, z component. Vx plus Vx I cap plus Vz k cap. So Vx I cap means here. So from this Vx I cap means Vx equal to, means along x axis. So there are two forces. One is, so by the magnetic field along this component V sin theta there is no answer, and V cos theta is having the velocity along I cap, and in z also there is one component. So with k cap. So now Vx is equal to, velocity is equal to acceleration into time. So q E naught by m into t. So this is along I cap by the electric field. So by the magnetic field, so V bar is equal to along Vx and Vz, xz, because field is in y z axis, means j axis. So the velocity of the particle in xz plane. So in helical shape. So now Vx is equal to now. So V cos theta. Theta means here you know again omega I cap plus V. So this is Vx and Vz sin theta j cap. Sin theta j cap. And here A also, the particle have A along x and z only. So the particle is having acceleration is equal to xi cap, axi cap plus az j cap. So along field direction there is no force, so acceleration also not there. So here k cap, az k cap. So axi cap and az k cap. So now you see this is ax, vx now. Okay, vx only, sorry. So now I can write formula a bar is equal to, so ax I cap. So here ax is two components along I, that is, and here if you see, so one component is, and if you see here the force by the magnetic force, the acceleration how much is coming, that is means velocity in what direction, first of all find out direction of velocities. So that is v bar cross I bar, that equal to I cross j is k bar. So that equal to vz k bar plus, and here j bar cross j bar 0. So that's why vz k bar, the velocity of the particle is along z axis. Okay, by qvb. So here q v bar is equal to, I have taken x I cap, x and z along z. So z is vz k cap and vx I cap. So velocity in the plane, this is the velocity by the magnetic field in the plane along z and x. So now, first of all, write the equation, force equation, then you will get clarity. Force is equal to, so 1 is by force is equal to Fe plus Fm bar. So now force is equal to Ma, and here Q E naught, and here Q V bar. So Q E naught I cap will come here. So now F is equal to Q into V bar cross V bar. So now that equal to Q E naught I cap plus Q into the V bar is equal, I take Vx I cap and Vz K cap. So write down now Vx I cap plus Vz K cap cross V bar means B naught J cap. So now finally write down the force means here Ma that equal to, so A equal to Ma is equal to, I can go, so that equal to Q E naught I cap plus Q into, so I cross J, so that equal to Q Vx, so B naught I cross J is K cap plus Q Vz B naught into K cross J is I cap. K cross J is equal to I cap. So now the total acceleration Q naught by M plus Q Vz into B naught of I cap plus Q B naught Vx K cap. So now here Ax is equal to, from this equation, so this is A bar. So now Ax is equal to, Ax bar is equal to component along I cap, that equal to Q naught by M plus Q Vz into B naught. And similarly Ay is equal to, Az is equal to Q B naught into Vx. So now I know Ax is nothing but, Ax is equal to acceleration is d Vx by dt. So Ax is equal to d Vx by dt. So that implies d by dt of, so this is equal to, so here Ax is, means dVx by Vt is equal to, how much is coming? Ax, that equal to Q E naught by M plus Q Z into B naught. So now derivate once again this equation. So dVx, d square Vx by dt square with respect to t. So that equal, this is total is Q E naught by M is constant, so 0, not derivation term. And here, so I think here T's will come. Oh, no, T will not come. So here see, so this Vx will be derivated with respect to Z. So that equal to, so here with respect to x Vz, that equal to Q B naught into d Vz by Q Vz by dx will come. So does it Z is derivated, right, with respect to R by dVz by dt, right? So if you see dVz by dt is equal to Az, that equal, I can add Q B naught into Vx. So that equal to Q B naught square by M also there here. By M has to come for this term also, M has to come. Forgot to write here. So Az also by M will be there. By M whole square into the Az is equal to dVz by dt I have substituted, then this formula is there. So if you see now, d square Vx by dt square is equal to minus, so omega square into Vx. So this is the equation of SHM, right? So here omega is equal to, here I got omega value is, the omega is equal to Q B naught by M whole square, means omega square equal to this is, so omega equal to QB by M. So hence we got the SHM equation means, so here the velocity of this particle by the electric field along the x-axis Vx component is oscillating. So it is under the oscillation. Okay, it is following the oscillation principle. So when we know in simple harmonic motion, so A is proportional to mass x, means second derivation of displacement proportional to or equal to minus omega square x, that it will be in oscillation. That is one of the condition, right? So here also this Vx component is in oscillation. So now we'll prove for Vx equation. So we'll get the Vx derivation. So we know, so V is equal to then some A into sin omega t. Vx is equal to solution for SHM equation, then x equal to sin omega t plus y. The similarly here omega t. X equal to sin omega t, A is equal to some constant. So there it will be amplitude, here it will be some constant, that equal to what I will do. Now see, already Vx we know, that is, so in the case, now do this one with the derivation again, dVx by dt, that I will get Sin omega t is cos omega t, that is equal to a omega cos omega t. So this is other relation ax, right? Ax equal to a omega into cos omega t. So now we know. So here if you see ax there, so from ax here, next component dvx by dt. So dvx by dt is equal to, actually here it is dvx by dt is equal to in along the electric field direction, it will be u q naught by m, e naught q by m, that equal to a omega cos omega t. So finally this you solve. So we will get the solution of these equations. And here the omega is equal to, we know already, here you solved it. So substitute now, you will get a is equal to, so means a is equal to, you will get here after that e naught by b naught. A is equal to e naught by b naught. So where initially t is equal to 0. So here substitute t is equal to 0. So v is equal to 0. Okay, then vz is also v is equal to 0, means here ax will become, this total is become 0. So then we substitute eq naught by ax equal to eq naught by m, that equal to a omega into cos 0 is 1. Therefore a omega I will write now substitute omega is equal to b q by m. So m get cancelled, q get cancelled, a equal to e naught by b will. Okay, at t is equal to 0, the vz and vx is also 0. So then you will get ax equal to eq by m at t is equal to 0. So now substitute this a value here, then you will get in vx value, vx is equal to e by b naught sin omega is equal to q b naught by m into t. So this is vx formula. So finally the velocity along x-axis, means I cap, or in the field of E and B combination, is vx I cap. So in the diagram we see V has two components, one is x and z component, and x component is combination of magnetic field and electric field, right? So now, so this vx value in z component, already I have vz is equal to, see here vz value I want to find out. So then vz is equal to, somewhere I have written vz is equal to, means where I have written vz value. So ax right. Okay, here az is equal to dvz by dt. Az is equal to, this is dvz by dt. So there I will take, no, not vz. Az is equal to, here az value is there. So now az is equal to d of vz by dt. So that equal to, you can see az value is equal to q b naught vx by m. So that is equal to q b naught by m into vx. So vx just now I saw that is e naught by b naught sin of omega is equal again q b naught by m into t. So this is the equation I got, vx. So now this formula I write down. So here b naught and b naught get cancelled. So only here now vz by dt I will get q e naught by m into sin of q b naught by m into t. So these are the equations for az. Now I want to vz only. Vx I got already, vz I want. So I'll do integration into t also there. Here I'll do integration. So dvz is equal to get the vz and vx values, and we want to prove them. Those are that particle is accelerating, so which we use in cycloid, right? That's why these equations are solving. So dvz by it is equal to q e naught by m into, means integration here. So this will go this side, dt integral vz. So sin integral sin q b naught by m t into dt 0 to t. So therefore vz 0 to vz is equal to q e naught by m, and here cos omega t, this is q omega t you take, that is easy for us to solve it. Cos omega t, cos ax is equal to cos ax by a integral cos ax dx is equal to cos ax, means sin ax dx is equal to sin cos ax by minus cos ax by a. So that I will follow now. So this is omega I consider. So minus cos q b naught into t by m by, so into m by q b naught I will write. So that is equal to get cancelled, q b get cancelled, e naught by b naught. So now upper limit 0 to t. So minus vz is equal to minus cos omega t. So this is vz formula. So vz and vx I got. Vz is equal to e naught by b, and here omega is will come. Sorry, this is okay. Omega means this q b naught by b only. Yes, that means you will get vz is equal to E naught by B naught into cos omega t, and Vx equal to E naught by B naught into sin omega t, and omega is equal to B naught q by m. So these values are, so Vx E naught by B naught into sin omega t, and here Vz is equal to minus E naught by B into cos omega t. Otherwise here you can stop q naught E naught by m omega. This omega you can write to that is, so finally it is only the right answer, and omega equal to qb by m. So these are equation, simple harmonic equation in velocity. That means with velocity function of this particle in electric fields, when electric field and magnetic field are perpendicular, the particle accelerates in simple harmonically in the fields. So this is about the motion of a charged particle in field. So last simple topic and a somewhat important topic, it is motion of particle in field. So when it will not deviate, deviation. So deviation of the particle. Suppose this is the field region of the field, in field or outfield, one perpendicular field you consider. So when we know the particle is projected perpendicularly, it will take circular path, right? It will move in a circular path and comes out in this direction. It can come the same direction, is opposite to this direction, and this is radius of this circle. I mean, these are the tangents. The line joining the tangents to the center, this will come center, right? If it is the tangent to center. So like this, not like that, not here. These values are not onto the point, onto the center. So now, so this is the path. So tangents are joining this side. If you take this side clarity, the normals turn to the tangents, join at the center. So this angle is equal to this angle. So this is called deviation angle. So now when it will come out and it will not hit this side, so it is completing circular path with radius r, which is less than d. So this is the d, distance between the two plates where magnetic field lies. So now the r bar means r radius is less than d, distance between the plates. So r, I know the r is equal to mv by the radius of this particle is equal to mv by qb, is less than d. So that means b is greater than, so b will go this side, b is greater than mv by q into d. So when magnetic field is more value than this, and you can write magnetic field is equal to mv means root over 2mk by 2d. So when the value of kinetic energy and mass, the distance is considered already, some value will consider. So when b is depends on mass and kinetic energy, so the kinetic energy means velocity of the particle, it is also considered some value. So when field is maximum here, when mass of the particle is maximum, so when field is maximum, which is equal to root over 2mk by 2d, then particle will not emerge from the field, it will be inside and turns back. Suppose it is not like this. In this not case, r is greater than d. So for suppose r is greater than, this is the field region. So the r of the particle in the infield is, so particle is projected perpendicular to the field with velocity v. So it is taking the path like this. So now this angle is called deviation angle. This angle is called deviation angle. So now according to law of circles, the normals drawn to the tangent points, the normals drawn to the tangent points will take same angle at joining the tangents, right? So now this angle and this angle is same. So now this distance is d, the distance is r, right? So now sin theta is equal to, this is, here I can go, this is d now, same. Sin theta is equal to opposite by hypotenuse, that is radius r. So theta is sin inverse d by r. Here theta is deviation angle. So this is one more. So sometimes you'll ask to find the distance between entering and the leaving point. So entering and leaving point. To find out first, here theta deviation angle you have to find out. So which is equal to d by r. So deviation angle. So now the distance between these 2 points a and b, the a and b distance between these 2 points is equal to, so this is x and x, both are same, that equal to x. So x I can write here, x equal to opposite side, and this is r, radius of this path, qb by mb, mb by qb, right? So now 2 radius, that equal to, here x equal to what I can write, opposite by hypotenuse r, right? Sin theta, therefore r sin theta, 2 r sin theta. So that equal to 2 into x equal to r sin theta. Then 2x total is the distance between joining entering point and leaving point. In case of magnetic field is more than root over 2mk by 2d. Or b is more than mv by qd. mv by qd, this is mv by qd. The b is more than mv by qd. So then the particle will not touch this another plane, or it will not deviate, right? It will not emergent. Deviation will be there, this angle deviation. So deviation is equal sin theta d by r. Deviation angle is equal to the angle between the two normals joined from the tangent position according to circle law. So this is about deviation angles. I will come with some applications after force concept, the force between the parallel concept. So I have taken maximum time because all the questions and models I have to give in the same point. That is the reason. Thank you.